Hello friends, let's talk about recursive best first search. So recursive best first search is a recursive version of best first search algorithm. It comes under the informed search algorithm. And here it is a standard best first search version, but it is working in a recursive manner. So here it is based on the standard best first search, but it is working in a recursive manner. And its structure is simple to that of recursive depth first search, and will apply the depth first search functionality on it. And we know that there is the recursive depth first search in uninformed search strategy, in which the depth will be increased at a time till we'll reach the goal. So recursive depth first search will work on that. But rather than continuing indefinitely down the current path, it uses the F limit. So here, if you'll see, previously we have seen some of the heuristic values. So we have seen the heuristic function. We have seen the some evaluation function, and based on that, whatever value we are getting, based on that, we'll decide that which particular node has to explore. Now here in best first search, we'll use the F limit. So there is the F limit that we'll calculate, and this particular F limit is a combination of A star and the other criteria. So how we'll find out the A star value in the uniform cost search? So we have seen that, in the A star search. So in the A star search, we have seen that we have to find out the cost, and this cost is nothing but your G of n, and we'll find out the heuristic value, which is of H of n, and we'll add these two to get the A star value. The same thing we'll do here with the F limit, but with some other criteria. So we have the F limit variable to keep track of the F value of the best alternative path. So we have, we'll keep track of the alternative paths here, and we'll use the F limit for that. And we'll see that if we need to explore a particular child or particular path, so we use this F limit to do that. So this F limit, to calculation of F limit, we'll see when we'll see the algorithm. If the current node exceed its limit, the recursion unwind back to the alternate path. So here, as the depth first search, how the depth first search work? So let's say this is the state space diagram. So generally what we do in the depth first search, we go into one direction. So let's say I am moving here. So let's say this is the node that has been explored. Now after that, I'll explore this particular node. After that, I'll explore this particular node. If this is not the goal node, I'll do the backtracking. So here also we'll do the same thing. It is called recursion unwinding back to the alternative path. And we'll see which particular path is the alternate path. So we'll backtrack it and we'll again find out and search the other path. So it works in that particular manner. As the recursion unwind, this recursive best first search replaces the F value of each along the path of the backed up value. So here this F value is keep on changing of each and every node. If each and every node is allotted some F value, this particular F value is calculated, as I told you, based on the A star value, and we have some other condition. Based on that, we'll decide which is the F value, and this F value is keep on changing. And when it will change, when we do the unwinding, process. And for the condition to the unwinding process is written in the algorithm, that in which criteria or in which condition we have to do unwinding. The best f value of its children. So we'll see that how this f value will be change of this particular node based on their children f value. Okay. So that we'll see. In this way, the recursive best first search remembers the f value of the best leaf in the forgotten subtree and can therefore decide whether it's worth examining the subtree at some later time. So here what we'll do is, based on the f value, we'll decide which particular node has to explore next. If we think that that particular node which we are exploring right now, it is not worth to explore, so what we do is, we're not going to go into their child. Instead, we fetch the f value of their children, which we consider as an alternative path, and will consider later on. So for later on consideration, we store the f value as the f value of the parent node. That is also mentioned in the algorithm. So when we see the algorithm, all these questions, whatever you are having right now, will be or the doubt will be clear. So here what we have understood till now. So here we have understood that first of all, the recursive best first search is the variation of the best first search, but it is a recursive version. This is the first thing. Second thing, it works in a depth first search manner also, because we have to go in one depth, as well as here we have a variable called f limit. F limit. It is associated with each and every node. How will calculate the f limit? It is based on, it is similar to a star value. So how will calculate the a star value? We'll calculate the a star value with the path cost plus heuristic value. Based on that, whatever value will come, it is called a star value. Here, with one condition, it will become the f limit. Now, here what we do is, whenever we want to do unwinding, we update the f value of that particular node from where we are doing unwinding. Okay. And this, why we are doing that? So that the node that need to be explored, which we haven't explored, that may be explored later on. So for just consider in mind that later on we can update or we can go through this path again, we use this updation of f value. Okay. Now let's dig into the problem, and let's try to solve one problem or try to solve one particular example, and we'll see that how this RBFS works. Now, the problem is that, what is the problem? The problem is, as we know, this is the familiar problem, and you consider that this is the Romania state in which we have different cities, and the numbers here in between the cities are the cost, the path cost of the individual city. Let's say from Arad, if we want to go to Subui, or from Arad, we want to go to Zeren, or Rumniki Vilaka, we want to go to, let's say, Kairwa. So for that, what is the cost? It is written here. This is the path cost. Okay. Now here one more value has been given, that is the heuristic value of each and every node to the goal node. Let's say from Arad, we want to go to the goal node. So what is a goal node? Let's say this we consider as an initial node. So this is my initial node, and this is my goal node. This is my goal node, which is the Bucharest. Now, what is our objective? Our objective is to go from Arad to the Bucharest and find out the path, how we'll go. And that path we'll find out using the recursive best first search. So we'll use this particular algorithm to find it out the path. Now, as I told you, this particular value, which is stated in front of the city, is nothing but the heuristic value. So this is the h value of any city. So let's say the h of Arad is 366, means it will be calculated based on some, as we have discussed, that how we'll calculate the heuristic value. We have seen that Euclidean distance. We have seen that simple straight line. So let's say if from here, if you want to draw a simple straight line from the Bucharest, so the cost of that particular line is taken as the heuristic value, and this is here, which is written is 366. Likewise, from Subui, let's say we want to go to the Bucharest with a straight line. So what is the heuristic value for that? It is 253. 253. So as you can see, this is the heuristic value, right? For the straight line, if we'll apply the straight line from one city to another city, this is the way, right? So let's say if we want to go from here to the railway station, if we want to go to the straight line, so what will be the kilometers? So definitely it will be less, but how we'll go? So we'll go to a particular road, we'll find out the junction, then from there we'll adapt any of the road, and we'll again go to another junction, and we'll go in that way, we'll go, right? Based on the road, it is not a straight line that we are moving, but here this heuristic has been made based on the straight line. Okay, so you understood this, I think. So what we have seen, this is the problem. The problem is from Arad, we have to go to the Bucharest. So Arad is the initial state, and Bucharest is the goal state. Okay, and these values are nothing but the heuristic value. Some h value are given, and this is the path cost between two nodes, which is also already been given. Okay. Now let's see the algorithm and try to solve that particular problem. Now, this is my algorithm. If you can able to see here, recursive best first search, and what we provide in the algorithm, we provide the problem. And what we are returning, we returning the solution or failure. So if the goal state is there in the state space diagram, so definitely solution, you will find the solution. Otherwise, this particular algorithm will give you failure. Now, what we are returning RBFS. RBFS is the short form of that, and this is a separate function. And we are returning this function with the problem. Problem is nothing but, let's say this is the state space. This is your problem. And then we'll call this particular function, which is called make node. Here we have the initial node, and this infinite value has been given. Okay. So I'll tell you what do you mean by that. Initial state is nothing but initially, this initial state is Arad. So we'll make Arad as the initial state, and infinite is nothing but the F limit. We know, we just seen the importance of F limit here, because based on the F limit only will we have to make the decision. So there is a F limit, and initially this F limit for Arad is infinite. Now let's see the function definition for this recursive best first search. The function definition is written. What we are doing is we are taking the problem. Let's say this is your state space. This is state space is your problem. The initial state is given, the final state is given, the path cost is given, the heuristic value is given. All these are your problem. Then node is your, so initially node is your Arad, right? So Arad is your node. And what is the F limit? So initially we have initiated with infinite. Okay, so I'm just writing here this particular line, so how it will be executed. So I'm writing just here. Okay. So I'm writing a function which is called recursive best first search. And what it is taking, it is taking problem. It is taking node. So first it is Arad. So Arad is my initial node, and F value, what is the F value here is infinite. F value is infinite. Okay. Now that we have done, and what it is going to return, it is going to return a solution. If it is not returning a solution, what it is going to return? The failure, and failure with F cost limit. So we'll talk about this F cost limit. F limit we know, but what is F cost limit, that we'll discuss. Now, the first line is if problem dot goal test, we'll do the goal test with the problem and having the node. If it is the goal, we'll return that particular node as the solution. So what is my goal node? So we know that the initial node is Arad and goal node is Bucharest, right? This we know. So whether this Arad is the Bucharest, no, it is not. So this condition is not satisfied. Then what we do is we create an array. That name is successor. So we'll create an array and we'll give as successor. Successor is 1. Successor is 1 array that we have created. Okay. Now, next line is for each action in problem, action state node dot do. Now we are in the state. What is the state node? What is the node right now? I am in Arad. From Arad, I'll apply all the actions. So what are the action we have? I can go from Arad to Zaran. I can go from Arad to Sukhoi. I can go to Arad to Timasara. So I'll explore all the actions that I can take from one node to another node. And after that, what I'll do is I'll add all the child that I'll have into the successor. Okay. So what are the child I have? So from Arad, I can go to Zaran. From Arad, I can go to Timasara, or from Arad, I can go to Subui, right? So what I'll do is I'll take the initial name of all the cities. I'll not write the city name as a whole. I'll take the initial name of the city. So from A, I can go to Z, I can go to S, or I can go to T. Let's do that. So I'll just do it here. So Arad is there, right? From Arad, where I can go? I can go to Zarand. Second, where I can go? I can go to Timaseara, or I can go to Subai. Yes, these are the 3 cities. What is the cost from Arad to Zarand? From Arad to Zarand, 75. This is the 75. This is 75. From Arad to Timaseara, it is 118. 118. From Arad to Subui, it is 140. 140. Okay. It is 140. Now, the second thing, what I'll do is that I have done. Now I'll put this into the successor list. I'll put this into the successor list. So let's say Zarand, sorry, so Subui, second is let's say Timasara, next is let's say. So I am putting into the successor list. Now the next thing what I'll do, if successor is empty, then return failure. Do my successor is empty? See, in my successor, there are 3 nodes. It is not empty. So this condition is not at all satisfied. So I'm not going to execute that particular failure, right? Now what I'll do is for each S in successor, now there is a loop on successor. I'll do what I'll do. I'll update the F with value from previous search, if any. Now what I'll do is I'll use the F value. I'll use the f value. Now, what is the f value here? Now you can see the f value here is infinite. Initially, it is infinite for Arath. Now I'll consider the f value of the previous, and based on that, I'll calculate the f value of each successor. Now, how can I calculate? So first, I'll see the first one, which is this is Zeranth. So for Zeranth, I'll calculate the path cost plus heuristic. Second, I'll see the previous node f value. So what is my previous node f value? What is the f value for Arath? It is infinite. So I'll consider these two, and whoever is sorry, this f value is different, f limit is different, right? So I have to calculate the f value for that. So previously, what is the f value of for the Arath? What is the f value? So for Arath, the f value is f value, and there is another which is called f limit. Okay. So what is the f value for each and every node? This particular f value is what is the path cost plus heuristic. So what is the path cost? The path cost here is not there, right? Because I am in the initial list. So I am in Arath. So path cost is 0. What is the heuristic value? So heuristic value is 366. So path cost plus 366 means 0 plus 366. It is 366 is my f value. Okay. So the f value of A is 366. Okay. Now the f limit is infinite that I have taken. F limit is infinite that I have taken previously. Okay. So this f limit, I'll put it like this. In another diagram. Okay. This is infinite. Okay. Now I have to calculate the f value for each and every successor. Let's say we'll start with the Zeranth. So what is the f value of the node is 366, which is the node Arath. Now, what is the path cost and the heuristic value for Zeranth? So what is the path cost for Zeranth? As you can see, it is 75. And for Zeranth, what is the heuristic value from for Zeranth? It is 374, and it will be added with the path cost. The path cost is 75. The path cost is 75. So it is coming 449. So what it is coming? It is coming 449. So now 449 and 366. What is maximum in these two? What is maximum? What is maximum? Maximum is 449. So 449 will become the f value for Zeranth, right? So we'll do that for each and every node. So this is 449 for Zeranth. Now we'll do for the Timasayara. For the Timasayara, what is the cost? Path cost is 118. The path cost is 118. Let me write it clearly. 118. The path cost is 118, and the heuristic value for Timasayara is 3. 118 plus 329. It is 447. Is 447 is greater or 366 is greater? Who has maximum? So definitely 447 is maximum, right? So we'll write 447 as the f value of Timasayara. Now go for the Suboi. What is the path cost for Suboi? It is 140. 140. And what is the heuristic value for Suboi? So heuristic value is written here. It is 253. So it is 140 plus 253. How much it is? 140 plus 253. It is coming 393. How much it is coming? It is coming 393. 393. Okay, 393. Now, what I'll do is I'll go for the next line. What is the next line? I have done this, right? So this process is over. So what I have done, I have calculated the F value for each and every node in the successor list. So I have 3 nodes, Zaran, Timaseara, and Suboi. So I have done that. Now I'll go to this particular portion, which is nothing but the loop. Now we'll find out the best. What best? This is the best. Best is one, you can say variable. So what is best? Best is nothing but the lowest F value node in successor. What is the lowest F value node in successor? So in successor, we have Suvai, we have Timaseara, and we have Zeran, which is the least one. 393, which is Suboi. So Suboi is my best. So I'll write Suboi is my best. Next is if best.f. What is best.f? What is best.f? Best.f value is 393 is my best.f value. Now this best.f value is greater than f limit. So I'll write 393, or I'll just put into other. This is 393. This is 393, right? So is 393 is greater than f limit. What is f limit? What is f limit? F limit, what is f limit? F limit we have taken as infinite. So it is greater than infinite. 393 is greater than infinite? No, not at all. So we'll not execute the rest one, right? If it will be greater than, then it will be return failure. But it is not, then it is not returning any failure. Now we'll find out the next one, which is an alternative. We have to find out the alternative. What is alternative? The second lowest F value among successor is the alternative. So who is successor? The next best. 393 is the first best. The next second best is 447, which is for Timaseara. So this Timaseara will become my alternative. This will become my alternative. Now what we'll do is we'll again call RBFS. What we'll call? RBFS. And we'll give the same problem. Best will be my node, and minimum of F limit or alternative, whatever the minimum is, it will become the F limit. So we'll call the RBFS this same function. But right now we have the problem. The same information will pass on. Now what is the best? Best. What is the best? Best is what? So Suboi is the best. Suboi is the best, right? Next is the F limit. F limit, right? This F limit. What is F limit? How will calculate the F limit? Here we'll calculate the F limit by this function. F limit comma alternative. What is F limit? Previous F limit. You will see here previous F limit is infinite. So minimum of infinite comma alternative. What is alternative? Is Timaseara. Timaseara's F value. What is Timaseara F value? Is 447. Is 447. Now whichever is minimum, infinite is minimum or 447 is minimum. Definitely 447 is minimum. So we'll pass here 447 as a F limit. So right now what is my F limit? So my F limit is My F limit is 447. Got it? Now, the same thing we'll do. We'll come here again. This is my algorithm, which is start from here. Now, what this algorithm says that problem node F limit, we got it. If problem dot goal test. So what is the node we have right now is Subui. So Subui is this goal state? No, it is not the goal state. Then what we'll do is we'll find out the successor as empty. So we'll create an empty successor. This is the empty successor we have created. Now this empty successor will apply the loop if action in problem action node state do. What we do is we'll find out all the action and find out all the child and we'll put the into the successor list. Okay. So what are from Subui where we can go? We can go to Orandia, we can go to Arad, we can go to Fegaras, we can go to Remnuki Villaka. So we have 4 options from where we can go, right? So we have 4 options from Subui. So from Subui we have 4 options. So first option is what? Let's say Arad. Arad is my first option. The second option is, let's see the diagram. What is my second option is Orandia. Let's say Orandia is my second option. O. Then where I can go, next option. What is my next option? Next option is Fegaras and Ruminiki Villaka. So let's see Fegaras. Ruminiki Villaka. Okay. I'll write the path cost for each and every. What is the path cost? 140, 151, 9980. 140, 151, it is 99 and it is 80. Am I correct? Yes. Now we'll do the same process again. So we'll put into the successor list. Let's say from Nikki Villaka, Garas, Orandia, and Arath. Okay, this is my successor list. Now, what is the next thing that I need to do is just see this algorithm for each action that we have done. For successor is empty. Is successor is empty? No, successor is not at all empty. There is some value on the successor. Now, what is the next thing that we have to do? The next thing that we have to do is update the f value. F value. F value. What is f value? F value will find out by this particular function. That function is a max function. First, we'll find out the A star path cost plus heuristic, and we'll compare with the previous f value. If the previous f value and this f value, will compare it. If the newly one is the same, is the maximum, then we'll consider the newly one. Other, we'll take the previous node f value. So we'll calculate one by one. Let's calculate for Arad. Let's calculate for Arad. Now it is 140 plus 140. So it is 140 plus 140 plus for Arad. What is the f heuristic function? It is 366. Now we got 646. 646. Is 646 is greater than 393? So whichever is large. So definitely 646 is large. 646. This will be my f value here, 464. Now for the Orandia, what is it? 140, 151, 140 plus 151 is the path cost. Here 140, 151. This is the path cost, the total path cost. plus heuristic of Orandia is 380 plus 380. I am getting 671. 671 is larger or 393? Definitely 671 is larger. 671. Now the next one is Fagaris. 140 plus 99 plus. Let's see the heuristic value of Fagaris. Yes. 176. It is 415. Is 415 is larger or 393? Definitely 415 is larger. Next is the RV, Rumniki. So it will be 140 plus 80 plus 193. 193. It is coming 413. 413 is bigger or 393 is bigger? 413 is bigger. So I'm writing 413 is the F value here. Now you got the F value of each and every node. Now next loop. What is the next node? We'll find out the best. The lowest F value node in successor list. Which is the lowest F value here is definitely RV, which is the 413. So RV is my best. RV is my best. Now the next one is F value of the best is greater than F limit. What is the F value of the best? Is 413. 413 is greater than F limit. What is the F limit? What is the F limit? 447. 447. Is it? 413 is greater than 447? No. So will not execute this. Then alternative. We'll find out the alternative part. The second lowest F value. What is the second lowest F value here? The second lowest F value is Fagaris. Fagaris is my second alternative value. Now I'll call again RBFS with the problem best with minimum of F limit. So let's calculate this. We'll call the RBFS here. With the problem. What is the best? Best here we find is RV, right? I'm writing Rumniki Vilaka, right? And what is the F limit here? So for calculating the F limit, we have to calculate the F limit and the alternative. So what is the alternative value of F value of alternative is alternative will be your Fagaris. So Fagaris value is 415. Let's see. It is 415. My F limit, which we have already calculated here, the F limit is 447. So whichever is minimum. So definitely 415 is minimum. So I'll consider 415 here as a F limit. Now this F limit will be changed to 450. I hope you understood this. Now the next node that we have to explore is RV. Okay. So RV has been applied here as a node. This RV is a goal node. No, it is not a goal node. Then we'll create a successor for that. What is the successor of RV? So from Rumniki Vilaka, we can go to Sudui, we can go to Pitasti, we can go to Karaiva. Okay, so three places we can go: Sudui, Pitasti, and Karaiva. Let's see. From RV, we can go to three places. One is Sudui, another is Karaiva, another is Pitasti. What is the cost? So Pitasti, it is 97. Caraivo, it is 146. And Subway, it is 80. It's 80 for Subway. Okay. Now I'll put those into the successor list. So let's say I'm putting Pitesti, Caraiva, and Subway. Okay. Now I'll calculate the F value for each and every node in the successor, because successor is not at all empty. So this particular is not at all execute. Then we'll calculate this. So we'll calculate this and we'll compare with F node, the previous F value of the node. Whoever is maximum will take add as well, F value, right? So let's calculate this. Now for calculating, that is 140 plus 80. Okay. So it will be 220. Now 220 plus 80, it will be 300. 300 and Suboi, from Suboi is 253. 300 plus 253, it will become 553. Now 553 is greater or 413 is greater? Who is greater? So definitely 553 is greater, right? Now the same thing will do for this particular city. It is 140 plus 80, it is 220. 220 plus 146 plus heuristic value of Caraiva. Heuristic value 160. It is coming 526. 526 is less or 413 is less? Definitely. Sorry, 526 is greater or 413 is greater. So 526 is greater. Now, Pitesti, for that again, 220 plus 97 plus, for Pitesti, what is the heuristic value? It is 100. Now it is coming 417. 417 is less or 413, sorry, 413 is less, right? So we'll write 417 as the maximum value here. Now we have calculated the F value. Now go to the loop. What that loop is saying? Loop is saying that find out the lowest F value. Who is having the lowest F value? If we'll see this, who is having the lowest F value? Pitesti having the lowest F value. So Pitesti will be my best. Testi is my best. Okay. Pitesti. Okay. Now the next one is this. What is this? Best F. What is best F? Is 417. 417. Is it greater than F limit? What is my F limit? 415. Yes. 415. So 417 is greater than 415. Yes, this condition satisfies. So what we return? We return failure. What we return? Failure. And apart with the failure, what we return? Best of F. What is best of F? Best of F is 417. That will return along with the failure. So what we do? And this 417 will return as this, and this will be changed to 417. And there is a failure. If there is a failure, so this particular is no longer will be required. And will go into our previous function. Now what I'll do is, because it is a failure, so this I'll remove. So I hope you understand why it is a failure, because this condition is satisfied and it is returning failure, and along with the failure it is returning the best of F value, right? Now what? Because I don't want to explore this, so I'll remove this. And this value has been updated. What it will be updated from 413, it will become 417. So So from 413, it will become 417, right? Now, I'll apply the same into this particular list, the successor. Now, in this particular successor list, because I have already calculated the F value, now I have to calculate the best and successor for that. Now, what is the best here? What is the best here? Best with the F value, least F value. Who is having the least F value in this particular diagram? 647, 646, 671, 415 or 417. So definitely 415 is less, right? 415 is less. So 415 will become my best, which is will become my best. Now the next one is the Figueras F limit. What is it? 4 what? 415, 415, 415, 415 is greater than F limit. What is my F limit? What is my F limit? F limit is 447, right? Because there is no longer that particular function. So that has to be updated as 447. This is my F limit, right? So here, my F limit is 447, right? This is 447. Okay, now 447, is it greater than 447? 447, no. 415 is not at all greater than 447. So what we do, we find out the alternative. What is my alternative? Alternative is RV. RV is my alternative. Alternative is RV. Now the next is RBFS with the problem best and minimum of F limit. So we'll apply RBFS problem. What is my best value here is Figueras. And my F limit. How I'll calculate the F limit? F limit was 447, right? What is my alternative path F limit? RV. What is the F limit here for the RV? It is 470. It is 470. Which is minimum? 470 is minimum. So 417 will be taken as a F limit. Now I'll change this F limit to 417, and this 417 belongs to heart Figueras. Right? Done. Now what I'll do is I'll explore Figueras. Now if I'll explore Figueras, how it will go? Let's see the diagram. From Figueras, where we can go? From Figueras we can go Sugoi, we can go Bucharest. Only two alternatives. So either I can go to Sugoi or I can go to Bucharest. For Sugoi, the path cost is 99. For Bucharest is 101. Sorry, 211. Right? Now we'll calculate the we have taken the child, and then the successor, it should be empty. Successor should be empty. And we have two, either I have Sugoi or I have the Bucharest. Then what I'll do is I'll see whether the successor is empty. No, not at all. Then we'll find out the F value for each and every successor. This F value of the previous node is 415, that we don't have to forgot. And then we'll calculate this value. This should be greater than 415. Then this value will come. Otherwise, this value will come as a F value. So we'll calculate this. Now 140 plus 99. 140 plus 99. 2 plus 99. 140 plus 99 plus 99. It will be 338 plus the heuristic value for Suboi. Heuristic value for Suboi. It is 253. Now it is coming 591. 591 is greater or 415 is greater? Definitely 591 is greater. Now for the Bucharest, we'll calculate the same thing. It will be 140 plus 99 plus 211. And for the Bucharest, the heuristic, because this is the goal node, the heuristic is 0. If you want to see, you can see here. For the Bucharest, the heuristic is 0. For the Bucharest, the heuristic is 0. Then it will be 450. 450 is greater than 415. Yes. So I'll write 450. Now, which is less? Bucharest is less, right? So I'll calculate. Next, I'll calculate the best. Okay. Now, what is the best? Best is the Bucharest. Now, F value of best is, we have just calculated, is 450. 450. Is it greater than F limit? What is my F limit? Previously, I have calculated the F limit, right? The F limit is 417. It is 417. So 450 is greater than 417. Yes. So this condition holds. So what we do with, if the condition hold? If the condition hold, will return the failure and will return the best of F. What is my best of F? Best of F is, who is the best? 450 is the best. So 450 will return, and this 415 will change to 450. And because this is return the failure, will go to the previous one. So what we do is we just remove this particular tree. Why? Because we are not going to explore it further. And this will be changed to 450. The F value is going to change to 4. Right. Now, next, so the previous one is, and I will erase this because it is of no use right now. What is my previous function? Because it is a recursive, right? So we have done with, then we'll go to the previous one. Again, the problem, Subhai, and right now, it is 447. What is it? F limit. So I'll just update the F limit here as 447. This is of no use, so I'll just remove from here. Right now, from successor, RV, Pegasus, Orandia, and Arad. What is the less? Which is the less for Suboi? So RV is the less, 470, right? RV is the less. So for RV, because from here up to here it is done. What is the best in that? Because successor value, this heuristic value, we have this F value already calculated here, right? These are the heuristic value which is in the oval shape. So now we'll find out the best. Best is best in the successor. What is the best in the successor? Is RV. Rumniki-Vilaka is the best with 470. So we'll consider Rumniki-Vilaka as the best. Now after that, best of F, which is 417, is it greater than F limit, which is 447? Yes. No. It is not. It is not. 417 is less than 477. So this condition doesn't hold. So failure not will occur. Then we'll find out the alternative. What is the alternative here? What is the alternative here? What is the alternative here? Now you can see The alternative here is the 450. The alternative here is 450 because with the 417, next is the 450. So alternative is Pythagoras with value what? What is the value here is 450. Now what we'll do is we'll call RBFS with the problem, best and minimum of these two. So we'll call RBFS with problem. What is my best? What is my best is Rumni ki Vilaka. And what is my F limit? So F limit you can see here. How we'll calculate? The F limit, the previous F limit is 447 and the alternate F limit is 450, which is minimum, which is minimum, which is minimum. 447 will be minimum. So 447 will come here as a F limit. So F limit is 447 is for RV. 447 is the F limit. Okay. Now the next we'll explore RV. We'll explore RV. When we explore RV, where we can go? We can go to Suboi, we can go to Karaiwa, we can go to Pitesti. So SCP. So I'll just write here S C and P. Let's write down the path cost. Individual here is for Suboi 80, 146 and 97. 80, 146 and 97. Now I'll calculate the F value. F value, it is 140 plus 80, it is 220. 220 plus 80 is 300, right? $300 plus for Suboi, what is the path cost? Path cost 253. 253 plus 253. 553 is greater than 417. Yes. For India, what is it? 220 plus 146 plus SC 160. 526. 526. 526 is greater than 417. Then again we'll calculate 220 plus 97 plus what is the heuristic value? What is the heuristic value for Pitesti? It is 100. It is 417. 417 and 417. Whoever is greater? Both are same, right? It is 470. Now in the successor of this, what will come? So Pitesti will come, then Serendia, then Suboi. Okay, we have three cities. Three cities has been explored. Now F value has calculated. Now go to the next one, which is this particular loop. Okay. Now this loop will find out the best. What is the best? The best is Pitesti. Pitesti is the best. Now Pitesti's best F is 417. 417 is greater than F limit. F limit is 447. If you are not remembering, you just go here. F limit is 447. F limit is 447. We have already done 447 is the F limit. Is it greater? No, it is not at all greater. Then this is not going to satisfy. Then what is the alternative? Alternative is, what is the alternative path here is, it has T. This one is the alternative path, which is C for Sarajevo. It is my alternative path. Okay. Now we'll find out we'll call the RBFS with the problem and the best. RBFS with the problem and the best is what? Bit ST. And what is the F limit here? F limit will be, just calculate the F limit. What is the second best I have? Sarajevo, and for that it is 526. Let's see, what is it? 526, and it will be 447. It will be compared with 447 F limit. What is minimum? So definitely 447 is minimum. So we'll see here it is 447, right? So limit is the same, 447, and we'll explore this one. Right now, Pitasti, let's explore Pitasti. From Pitasti, where we can go to Bucharest, or we can go to Rumniki Vilaka. So let's do that. We can go to Bucharest, or we can go to Rumniki Vilaka. To go to Bucharest, what is the path cost? Here it is 101, and here it is 97. 97, 101. Let's calculate the F value here, and for F value here. So it is 140 plus 80 plus 97 plus 101 is 418. 418 is greater than 417. Yes. Now, it is 414. 414 it is coming here, which is 417. It is the F value here. Whichever is maximum, 417 is maximum. That will come. Okay. One 80 and 97, and again 97. Okay, wait a minute. I have to calculate the heuristic also here. Heuristic also, because Bucharest is the goal node. That's why the heuristic is 0. Let's calculate the heuristic of RV. 193. So it is coming 607. It's coming 607. So 607 is greater, or 417 is greater. 607 is greater. Now it is correct. Now what is the successor here? Is to Bucharest and RV. Right. Now let's calculate this. We have calculated the F value here. With this thing has been done. Now what is the best? Best, we find out the Bucharest is the best. Now what is the F best? It is how much? 418. 418. So 418 is greater than 447. No, not at all. Then it will not return failure. Then we'll find out the alternative. What is my alternative? So alternative is the one only, which is the RB. Now we'll find out the RBFS with the problem, and the best is Bucharest. Now what is the F limit? F limit the minimum of these two, right? So F limit was 447 previously, and the alternative F limit is what? 607. 607. Sorry, F value, alternate F value, 4607, which is minimum. 447 is minimum, so 447 will come here. F limit is the same. Now we'll explore BR. Now for BR, you can see here, it is coming BR here, limit is 447. It doesn't matter, the problem is given. It is a goal. Yes, it is a goal. Then we'll return the solution. Now here, your solution will be written. Why? Because we reach the goal node. This is the goal node that we have to reach. What is the path? The path is from here to here we can go, from here to here we can go, from here to here we can go, and from here to here. Means from Arad we can go to Suboi, from Suboi we can go to Ruminiki Vilaka, from there we can go to Pitesti, then we'll go to Bucharest, right? And this is the app value for that, and the path cost is the same, is 418 is the path cost. Now you can see the diagram also. So recursive best first search is giving you the path. From here to here you have to go, from here to here you have to go, from here to here you have to go, and then you'll go here. If you'll follow this particular path, you'll reach to Bucharest with 418 path cost. And this is the minimal or the optimal value to reach the Bucharest, right? So this is how the whole RBFS work. It is a bit lengthy and it is taking a lot of time to explain. So I hope this video is very much useful for you to understand RBFS.